Peter asked the question, if every person on Earth points a laser pointer at the moon, will its color change? The answer, no, if we use ordinary laser pointers. The first thing to consider is that not everyone can see the moon at the same time. We could gather everyone in one place, but we've already learned the lesson of how difficult that is. Most of the Earth's population lives between 0 and 120 degrees east longitude, so our chances of illuminating the moon will be best when it is over the Arabian Sea. We will wait for a quarter moon to observe it at night and compare the effect of our lasers on the dark and light sides. A typical red laser pointer has a power of about 5 milliwatts, and a good pointer will have a narrow beam capable of reaching the moon, although it will spread across much of its surface. Assuming everyone has a stable aim to hit the moon, and light is evenly distributed across its surface. This is what happens. Nothing. It makes sense. Sunlight illuminates the moon and Earth with power just over 1 kilowatt per square meter. Since the cross-sectional area of the moon is about 10 trillion square meters, the bright half receives about 6 times the sunlight, while our planetary assembly of 5 milliwatt lasers adds only about 30 megawatts of illumination, which is 200 million times weaker. We definitely won't notice the effect of lasers. What if we try more powerful lasers? All right. A 1-watt laser is extremely dangerous. It is powerful enough to blind you. It can burn skin and ignite objects. These lasers are not strictly illegal, but there are restrictions on their sale in the US, leading to suspicious offers for 1-watt lasers with very narrow beams. I saw one of these suspicious lasers in person, and they are truly frightening. You definitely shouldn't handle one of those without wearing protective glasses that cost more than the laser itself. So, let's assume we spend $1 trillion buying 1-watt lasers for everyone. That's the effect. Wow. All these laser pointers illuminate the surface of the moon with a power of about half a lux. This is roughly half the brightness of moonlight that we perceive on Earth. 330,000 lux from the sun still overshadows the lasers. What if we try even more powerful light sources? We will have to leave the lasers and instead give everyone a night sun. This is a searchlight mounted on police and coastal helicopters. With a power of about 50,000 lumens, it can turn a patch of land from night into day. The beam has a width of several degrees, so we will need some focusing lenses to narrow it down to the required half-degree angle to hit the moon. Visibility is not very good, but we are moving forward. Our collective beam provides 20 lux of illumination, exceeding the surrounding light on the night side of the moon by twice as much. However, this clearly had no noticeable effect on the bright side. What if we try to increase the power? All right, let's replace each night star with an IMAX projector, a couple of water-cooled lamps with a power of 30,000 watts, and a combined brightness of over 1 million lumens. Still barely noticeable. At the top of the Luxor Hotel in Las Vegas is one of the most powerful searchlights on Earth. Let's add a lens to focus the beam on the moon. We'll cover it with a colored filter and distribute it to everyone. Good. Our light is definitely visible. So, we have achieved our goal. Great job, team. What if we try even more power? All right, we'll have to return to the lasers. The Boeing YAL-1 was a laser pointer the size of a Boeing 747. Literally, it was a megawatt-class infrared laser mounted on a Boeing 747 as an experimental technology developed by the U.S. Department of Defense. We can imagine creating a visible light laser with similar power and giving it to everyone. Finally, we managed to achieve the brightness of sunlight. We also consume 5 petawatts of energy, which is twice the average electricity consumption in the world. What if we try for even more power? All right. Let's place a megawatt laser on every square meter of Asia. The power for this array of 50 trillion lasers depletes Earth's oil reserves in about 2 minutes. But for those 2 minutes, the moon shines as brightly as the sun at noon. By the end of these 2 minutes, the lunar regolith heats up to luminescence. What if we try even more power? All right, we are about to go beyond plausibility, even further than we already have. The most powerful laser on Earth is the compression laser at the National Ignition Facility, a laboratory for nuclear fusion research. It is an ultraviolet laser with a power of 500 terawatts, but it operates only in pulses lasting a few nanoseconds. Thus, the total amount of energy it outputs is equivalent to about a quarter of a glass of gasoline. Let's imagine that we somehow find a way to power it and run it continuously. So, you give it to everyone, and direct them all to the moon. Unfortunately, lasers turn the atmosphere into plasma, instantly igniting the Earth's surface and killing us all. But let's assume that lasers somehow pass through the atmosphere without interacting with it. In such conditions, it turns out that the Earth will still catch fire. The reflected light from the moon is 4,000 times brighter than sunlight at noon. But forget about Earth. What is happening to the moon? Lasers emit enough energy to vaporize 2 meters of lunar soil per second. However, as soon as the pieces of moonstone evaporate, they do not disappear, but instead the upper layer of the moon quickly turns into plasma, which blocks the rest of the beam. As our laser continues to pump more and more energy into the plasma, it heats up increasingly, causing the most energetic particles of plasma to rush into space at incredible speeds. This stream of material effectively transforms the entire surface of the moon into a rocket engine. Remarkably efficient. The use of lasers to remove material from a surface is called laser ablation, and this method proves promising for creating thrust for spacecraft and maneuvering on the moon. The moon is massive, but we are dealing with a powerful plasma jet made of rock. A very rough estimate shows that the moon will be out of reach of our lasers in just a few months. During this time, the beam also cleans the Earth's surface and destroys the lasers, but we assume they are invulnerable. The moon retains most of its mass, but frees itself from Earth's gravity and enters an asymmetric orbit around the sun. This strange orbit is unstable, and ultimately the moon will either be thrown into the sun, leave the outer part of the solar system, or collide with one of the planets, possibly ours. I think we all agree that in this case, we deserve our fate. And finally, this is powerful enough.